Hey, how's it going, guys? So here we are back again on the Python BACnet stacked playground. We're burning through some material here. So like we did vibe code app 1 on back 0 and back pipes for just a read, write, release, and a read again. Vibe code app 2 was the, let's see, which one was this now? This was the read multiple. So that's a read multiple. We save data to a CSV file and rotate the CSV file. And back pipes to back 0. And this one was a priority array in both back pipes and back 0. And then right now we're on BACnet servers. So also a Discord channel right here. So just hit the button if you want to join a Discord channel. Feel free to ask any questions or chat with me or anyone else on the channel about any BACnet questions. So I have to revise this. We're kind of burning through material here faster than I thought. So right now we're just on this back pipes 3. We're already kind of doing this, the final project, and we're not even on day 21 of the theory lectures. So I think I have some more things we can do to fill in the time if we're burning through our apps real fast. So like we'll get into Docker container, systemd stuff, Linux fundamentals, Wireshark, maybe a little bit sooner because this is a big topic. So like when we're running back pipes servers, so we're just using tmux, which is a service you can download with Linux, and then you can just run an SSH session like a long term. So like when we were running on our BACnet scan tool yesterday that we've demoed a million times already, hit the search button. So like all of these devices populating here are running tmux. So this is my test bench, except for OpenFDD that's running Docker. That's more a sophisticated way of running Python scripts long term, but all of these were just running little tmux sessions on the Raspberry Pis in Linux, which is just a great way for test benching stuff, but it is not like a production way of running a Python script long term on a Linux device, because if the device ever power cycles or something, tmux doesn't bring it back to life, but Docker can, and also systemd. So maybe we'll get into some more sophisticated ways at running Python scripts long term. Okay, so if you remember from yesterday where we made a little script, we modified the backpipes server. So like that was here, backpipes 3 samples. So we were here, we'll just click on this one. I don't even know if I'll get into COV. We probably could, because it's a important concept in BACnet, but I honestly don't really use it much and prefer polling better than COV. COV is change of value notification, which can create a ton of BACnet traffic, even worse than polling if it's set up wrong. So I don't know, I just prefer polling. So here is BACnet, the backpipes sample application for the mini device. This is just a little BACnet server with a couple read-only analog value, read-only binary value, and a commandable. So like we modified this yesterday into the start of our web weather application. So yesterday, researched the video we did yesterday. We changed the name to, we created analog value 123 and then renamed it to web weather dry bulb, temp, humidity, dew point, and then we had to actually update the commandable analog value to address 5, because these all need to be unique, because when we discover these, this is how they discover. So the commandable points right here, you can actually write to these on the priority array, which we talked about earlier. So if we just write value of 55, it'll write to the device, and we would actually see it in our Python script if we ever needed to do anything with that. There are use cases for that. So like, for example, the building automation system could be writing a set point that it wants your BACnet application to use under the hood, and then you could be in Python world, you could be using that set point for if you're controlling something. So that's where you would use that. It's not very useful in a weather dashboard, which we'll use. So maybe we'll just delete these. And I don't even think, maybe we could change our read only into, if the app is good or not. So I think we might just delete these commandable points, but that's what they would be. That's what they'd be there for. So like you would be doing for a binary value, commandable, I think you would just be doing a 1 or a 0. So we would just do like a 1 on priority 1. Ta-da! So that's a binary value. But it looks kind of weird under the hood in Python. So in BACpipes world, even though on this interface it comes through as a 1 or a 0, under the hood, let's get into our mini weather device, just where we're at with this, like we would be doing, let's see, where is it? Commandable, binary value, and you set it as a string, as active or inactive. So just be aware of that. Like you were writing here as a 0 or a 1 for a true or a false, but under the hood in Python, it comes through as active or inactive as a string. So kind of confusing. Usually Boolean values in Python are a true or a false or a 0 or a 1. So just be aware of that. So I think we might delete that anyways. So okay, so where should we go with this? We should probably start modifying our app. So like we said, let's blast away our commandable points because we don't need them anymore. And then we could probably keep this as we'll be doing like a weather fetch. So web weather fetch. Okay. So this is like our request to the internet, and maybe we can set it as true if our web weather fetch is good. We have to delete that from here too. So we could call this a different name. We could call this as read only BV. I'm just gonna call it, I deleted too much. Web weather fetch. Okay. Would be kind of nice to have this abbreviated as a, maybe we should do this as a BV. Then these should be AVs because they're analog values. AV, AV. We just have to rename them in both places. Just so we have like this like little abbreviation. Then when we look at the point object here, that it has this little abbreviation for binary value, analog value, and then this is how you register the app with the backend Python BACpipe source code. And then we probably have to do, yeah, we have to update this too. And then this will be our BV. So at the moment, like we're just updating we demoed this yesterday, the web weather temp AV present value is just this value here. And then the BV will be next value. Looks kind of funny the way it's written, but it's just like oh yeah, so like see how we got into slicing a little bit with our theory lectures. So this will be slicing that value and then that value. So it's basically the piddly little algorithm just for testing purposes is just switching between these values. And we probably could run it. So yesterday we did we had 2 terminals open. split terminal, and then we did a SSH ben. Let's see, what's this? Shoot, now I can't remember what the IP address was. So we can actually check from our BACnet scanner. These Raspberry Pis were also imaged using the Raspberry Pi Imager, which is also kind of cool these days. There's lots of features where I highly recommend using that tool. It's kind of nice. And like, so 204.12. And I'm also imaged the Raspberry Pis to just, for SSH username and password, to use security dot key and pem. Okay, so if we do SSH ben at 192.168.204. Already forgot. 12. And because I set up the Raspberry Pi to do a login, not username and password based, but with like a security key and .pem file. It's a little more secure and it's automatic. It's kind of nice. And the Raspberry Pi image tool does that all behind the scenes. Makes it really easy. So I'm going to clear that terminal. And then we did my CD into vibecode app4 directory, list it. And then we did Control R. I can back search our commands. Closest related command should have been scp. Okay, here it was. Hit tab again. So that Control R finds the closest related command to the last scp, which I found it. And then I'm just gonna hit tab and enter. And then we did a scp, so that secure file copy protocol. And then it copied it over to here, which is the device, which is this device on my test bench. So I'm going to close out of that, and then we can get back into our tmux session. A lot of concepts here, so I'm good to soak all this in. So tmux-a, I think I can go back into our last tmux session, and I'm just going to restart it. And then just make sure there's no errors. Let's go back in here. Ooh, okay, so there is an error. Okay, we forgot to update this. Remember we blasted away those two points from our app. So we'll put that into there, that into there. So blast that away, and then we'll copy our file back over with secure file copy protocol from Windows to the Raspberry Pi. We start the Python file in Raspberry Pi, and like I'm just copying about 2 feet away from one computer to the other, but this could be copying anything from you could be copying to different continent. You can copy whole directories too of files. And like one thing you can also do in VS Code is you can SSH right into the Raspberry Pi itself, which is kind of cool. I'm not doing that here, but probably good to do that. Okay, so if we just double check this, just to make sure that our points look nice. Kind of nice having a Windows scan tool on the same test bench as your Linux Raspberry Pi devices. If this was in a remote building somewhere, I wouldn't be able to do this. Hopefully that makes sense. So see our points updated. So we updated the names and weather fetch, okay. So we'll actually do things with this in a little bit. So right now there's no logic connected to these other than this little algorithm here that's just switching between some values for testing purposes. So I wonder if this is probably a good place to stop on this today, because we probably have enough going on. So, oh shoot, So I want this to run. Remember, like if you SSH into a Raspberry Pi and you close out of your remote SSH session, your Python script will stop running. So that's where we'll get into more advanced topics of systemd and Docker. But this tmux is kind of an easy way to cheat. So right now, because this is green, it's just showing that we're in a tmux session. So I'll do a shortcut command of let's see, Control BD. No, that didn't work. Control BD. There we go. It's like a muscle memory. So like right now we detached from our tmux session, and I can close this SSH session to the Raspberry Pi and then test that our Python script is still running. So, which it is. So if our Python script died because we closed our SSH session, we would not be able to do any of this. This tool would error out saying like the device is not responding. So the device is responding, meaning that we're good. Okay, so where are we? So like we're up here, we got through that. Hopefully we can blast through theory lecture 22 today. So like I just Googled dirt simple Python script to print web weather, temp, and humidity, current outdoors. So here we go. Google, you can get this now, which is pretty cool. So I'm just gonna go here, and then on Windows, I'm gonna just do OpenWeatherMap. What should we call this? Tester.py. Let's see. So let's just do. Sure. Let's do Madison, Wisconsin, USA. Hopefully that'll work. Okay, so like what you need to do, so this is OpenWeatherMap API, which uses the request libraries in Python. So this is just a way to request data from the web. Like when we open up Google, ChatGPT, this is a request. Our browser is doing a request to a server, so that's essentially what we're doing right here. So really neat that you can get this through Google now. So you have to do a pip install this special request library from Python. Pip install that, like how we installed the BACnet stack with backpipes and iffitter a long time ago in these tutorials. Also have to do that with the request library. So then we could do okay, so let's test this out. I am here in OpenWeatherMap API. I think I have a login for this already. I thought I was logged into this. Hold up, I thought I had this all logged in, but apparently not. Sorry guys. So where are we here? At gmail.com. Well, this did work. This did work a minute ago. Anyways, maybe we'll have to save this for tomorrow. Oh shoot, I think I know. I just have to do my email if I can get this to work. I think it's worth just showing. See if I can bring this up real quick. So actually, sorry guys, I think I'll have to show you this tomorrow, but for tomorrow, let's get this to work, and then we can put it inside of our Python script to show this data as our BACnet objects for real temperature and humidity data from OpenWeatherMap API, which is more than likely better sensors than anything that the building can provide. Usually this data comes from like a local airport weather station, which would be a higher quality sensor than the local building automation system. Okay, I apologize for that. We'll get it working though tomorrow. Okay, so here we are. So let's do working with nested data, which is an important concept. Here's our theory lecture. Okay, so the goal is to manage nested data such as dictionaries and dictionaries of lists. Practice iterating through nested data structures with loops. So this is like nested data, which we saw this in our Python scripts a lot. So this is how you print key value. Should be kind of self-explanatory, except you have to like just practice it. And AI is really good at writing it too. Gosh, that's so annoying. I was logged into OpenWeatherMap just a minute ago, and now it logged me out, and I can't log back in. If anyone does request a free API key, it does take like an hour or two for them to approve of you, so it's not instant. It takes a little while to get your free API key. So you could do it now if you want to. Okay, so here we go. Let's see if we can blast through this quick and probably call it a day. So create a list of sensors with 3 dictionaries. The dictionary has keys, name, and reading. Loop over and print each sensor's name and reading. Okay, so I'll probably cheat here and just use this code. Create a list called sensors. Okay, sensors with 3 dictionaries. Just delete you. And just create one more. 3 dictionaries with keys, name, and reading. Let's see, name. Let's see, this could be E81. Reading. This can be a numeric value or a string. Let's just try something like that. Just gonna say 2, and whatever this will just be some random data. And then we could just say for sensor dot items. Let's see, I think we'd have to do for key and value in sensor dot items print key and value. I think we did all this before. Seems like kind of redundant lessons, but it's actually kind of good practice, I think. Python script lesson. Okay, so I think we have to do here. There. Why only so this is only printing the, okay, so like we have to do for item in sensors. Changing the names here. Okay, so that printed the same thing 3 times. So, okay, so maybe we could just let's try this. A little bit of debugging. Can't remember. Print item practice makes perfect, right? Oh, that worked. And we can even do some slicing. There. Oh, come on. It didn't like that. Well, whatever. Maybe this is fine. Good enough for me. I think we not satisfied. Printing. Okay, good enough. Since we're running out of time, write a loop that produces a dictionary mapping each room to default value of 72. So just say data equals that, and then just say for room in data. Actually, so call this final product as a dictionary, and then we would just say room, no, final so I think we're defining the key and the value equals 72. Print final. Okay, so here we go. So that worked. No, we've done this before. This is redundant. Given the schedule Monday through Friday, loop through the dictionary and print the day along with the start and end times. Okay, so we'll just say schedule. Let's just print the length of the schedule. See what that looks like. Should be 2 items. So there's Monday. We could even do print schedule dot keys. We could do like that. Monday, Tuesday. So it wants us to do it on a loop. So for item in schedule, print item Monday, Tuesday, and then we could say I also might try this. See if the slicing will work. Ooh, that didn't work. Let's just try the type. Item. Okay, so it is retrieving this as a string. Let's try this. For key value in schedule print key value. Ooh, Why am I struggling? I might have to just cheat and use AI because I am out of time for what I have to do here today, so at least we tried. So I just might have to do this a little bit. I know this is probably something really easy, like this. For day and times. See, knew it was really easy. This is describing that, and the slicing with a 1 is describing that. Ta-da! Okay, easy stuff. So I think tomorrow we'll do the OpenWeatherMap API key and get our Python script working to fetch web weather data. And then we'll have that project done of making a BACnet server with real data from the web. Hope you guys are enjoying this. More fun stuff to come. Have a good day.